There we go. Hello there, everybody. Welcome aboard. Last year, we discussed the relationship between things created by these two lines or line-like objects intersect, just like AB and DC do. Below, write everything you remember about that. What if I told you that the measuring angle AED was 34 degrees? See what you guys can do with that. And I'm going to get this story on the road, so you're going to want to pause. Let's get this going. Alrighty, everybody. Can I get you back up here in 5, 4, 3, 2, 1. Okay. So the first thing I wanted to talk about on this, guys, was to talk a little bit about the language of angles and lines, because you might not remember all of that, and we're going to add a little bit to it this year. So what we've got here, guys, is I've got two linear objects, right? One of them's a line and one of them's a ray. If I had actually done a much better job of doing this, I would have put little arrows on here and like one arrow on there, okay? So hopefully you have this drawn. If you don't have this drawn, make sure you do. And there's all these points that go through here that help define these things, right? You've got A, D, E, B, and C. I don't know if that's easier to see for you. And what we've got here, guys, is the line DC. We can write that as DC with a line over it like that. That's what this thing is. That's DC. That is to say it's a line that goes through those 2 points. That's all there is to it. This guy right here was ray AB. You don't have to worry too much about that. We don't use rays that much this year. But ray AB, which means we start from A, we go through B, and then it goes on forever. And it creates all these angles. And there's two ways that we can name angles. Yesterday, we talked about naming angles. Like I just put a little arc there and give it a letter or a number, like angle 1, angle A, angle C. You guys remember that? And the other way you can do it is if you do 3 letters to trace it. Like I told you about angle AED. That is, if I trace from A to E to D, that's the angle I'm talking about. When I talk about angle AED, it's like you trace it. You trace the angle we're worried about, okay? The other thing I mentioned on the warm-up was I told you that the measure of angle AED was equal to, did I say 38 degrees or was it 34? Was it 34? Equals 34 degrees. That is, this opening, thanks so much, this opening is 34 degrees wide. That's what I'm trying to say. Now, the whole point of talking about angles last year was that if you knew that the measure of angle AED was equal to 34 degrees, you could find the measure of angle AEC, you could find the measure of angle BEC, and you could find the measure of angle DEB. How many of us, after just talking about this much, are suddenly feeling some stuff tickling back into your brain a little bit? Like you can feel a little bit happening in there. Like I'll tell you right now, last year I remember there was 2 kinds of things you had to do with these angles, and one of them was always felt a little easier than the other one. Too many papers. Okay. One of them always felt a little bit easier. Like I'm going to tell you guys right now, if I know that the measure of angle AED is 34 degrees, I can tell you for sure what the measure of angle BEC is. That is, if I go from B to E to C, I know how many degrees this is now. When I say teach, I want you to say, okay, do you remember how to use the measure of angle AED to find the measure of angle CEB? Give it a try and teach! Okay, can I get you back up here in 5, 4, 3, 2, 1. Ava, do you remember? What would the measure of angle BEC be? It would also be 34 degrees. Do you guys know Desi? So Desi Desi, when I was asking what do we call these two angles, and she said congruent instead of vertical, which is what we were looking for. But she was also right that even though these are vertical angles, that was the relationship name, these angles are congruent. They will always have the same measure. Vertical angles always have the same measure, which is really nice to find them. How the heck am I supposed to find the other two, though? Because there was something that we did last year where I could do something with those 34s to find the measure of these other two. Why don't you guys talk about that for just a moment? Teach, teach! Oh, thanks, Macy. Muchas gracias. Can I get you in 5, 4, 3, 2, 1? Let's see here. I forgot how the alphabet works. Henry, do you remember how to find those other angles if I know that these guys are 34? I'm glad we're talking then. The hint here, guys, is that these form what's called a linear pair, which is to say, put together, they make a straight angle. Henry, do you remember how many degrees are in a straight angle? It is 180 degrees. That means put together, this green angle and this pink angle make 180 degrees. And if I know the pink angle, Henry, is 34 degrees, what could I do with 180 and 34 to find out what the green angle is? That is exactly what we do. Let's go ahead and open up our calculator. We got to do the song. Perfect. Thanks, Kaylee. That's all I have for you today. Not you at home. You guys are on the hook. TI SmartView, TM emulator software for the TI-30X/TI-34 multi-view. TM calculators, Texas Instruments, validating software license, ... Yeah, there you go. All right. So we're going to do 180 minus 34 because two angles that are that make a straight angle, we call them supplementary. You don't have to worry about that this year, at least not the name so much. They add up to 180. So if I take away the 34, that means that this green angle, AEC, has to be 146 degrees. That is, the measure of angle AEC is equal to 146 degrees. And I'm going to tell you guys right now, I believe you have enough information to tell me the last one. The measure of angle DEB. Oh, Deb. When I say teach, I want you to say, okay, now that I know all this, I can find that angle pretty easily. What is the measure of angle DEB? Give it a try, and here we go. Oh, Deb. Teach! Okay, can I get you guys back up here in 5, 4, 3, 2, 1? Kyson, what do you think? What do you think the measure of that angle is? Of this blue one right here, DEB. Yes, sir. It is also 146 degrees because vertical angles are always congruent. These two have to match. Also, these two have to add up to 180. These two have to add up to 180. That's how it goes. You can kind of circle around. How many of us? But let's dial those thumbs again. Big thumbs up, Mr. Petersen. I got a 4 on this skill check last year, and I would get it the same if I gave it to you right now. Big thumbs down. I'm still convinced I've never seen this before in my life. And also, I don't understand what you just did. And then dial it somewhere in between. Where is everybody? Hey, that's a nice big uptick. Not everybody. I saw some thumbs go down a little bit. They were like, I thought I knew this, but maybe I don't. But most of us came back up. Let's keep talking about it, guys. Let's see here. It is the 45th day of school, so 45 is the smallest odd number that has more factors than one more than itself. That is, if I list all the numbers that go into 45 evenly, just go ahead, every single one. No, 8 doesn't go in there. That's okay. 1 does. 9, 45, 3, 5, 15, and I think that's it. And then 46. 46 is one more than 45. What are the numbers that go into 46? Actually, 4 doesn't go into 46. I know, it looks like it should, but it doesn't. Nope, 6 doesn't go in there. Nope, 3 doesn't go in there. 46 does go in there. 26. Not 26, close though. 23. That's it. So 45 has 1, 2, 3, 4, 5, 6 factors. 46 only has 1, 2, 3, 4 factors. So 45 has got more factors than 46. Also, if you add all those factors up, you get a higher number than when you add all these factors up. There you go. It's Eat a Pretzel Day. Yay! You guys, I'm going to say, I feel like the pretzels in a bag are kind of mid. Like, you know, like the little pretzels that are like crunchy and in a bag. But I'm going to say, as far as snacks go, soft pretzels, those are S tier. Right? Absolutely. Like a soft, buttery, salty pretzel goes so hard, especially if you have a little bit like a little cup of cheese. You know what I'm saying? That sounds about. How many of us think that sounds pretty darn good right now? Yeah. Oh, I've never had the Disneyland ones. I mean, I don't mind the ones at the zoo. The ones at the zoo are just fine. But you know what? You know what? Those hit the hardest at a jazz game. That's what I'm gonna say. Callie, you go. Oh, Callie, yes, absolutely. Alrighty. Let's do it, guys. What is our first? Oh, I actually drew your card. Callie, on your way out, would you please read our essential question today?
What happens to the angles made by the parallel lines across
Let's go ahead and write that down. What happens to the angles made by parallel lines crossed by a transversal? Our Jeopardy this week is Famous Ben's. It's not the clock in Elizabeth Tower, but this Ben is rather the giant bell that the clock uses. Michelle? It is Big Ben. Big Ben is not the name of the clock. It is the name of the bell inside the clock. And then, that's good. You got it right. And then things that rhyme with hark, dark is what I'm looking for. Dark. Dark, indeed. All right. Let's see here, guys. Let's go ahead and we're going to do kind of a little practice and kind of a little, kind of something else here with this. So let's go ahead and write this down, guys. Got a pencil? Oh, got a pencil? Transversals 2. Now with angles. Like angle measures. So I want you to do something kind of odd here. I want you to draw a line like this that's actually kind of long. I want you to draw a line like this that's kind of long. Okay? And then a line intersecting it kind of like this. So it looks a little bit like a sword. Yeah, kind of like that. And we're going to call these right here. You know what? Let's just call it what it is. SWORD. It's a sword. It's a sword. And I'm going to tell you that the measure of angle SOW is equal to 151 degrees. Gesundheit. Once you do that, guys, will you put your pencils down for a second? Because I want to make sure we're all feeling really good about what I mean by angle SOW. Because not everybody feels super comfortable with this yet. And I want to make sure we're okay. Guys, which angle that I've got up here is SOW? Is it pink, blue, orange, or green? Everyone, it is the what? Everyone, it is the... It is the blue angle. The blue angle is SOW because I traced S to O to W. So I know that this angle right here is 151 degrees. Will you please tell me the measurement of the other three angles we see here? That is SOR, WOD, and ROD. Talk to each other. How could we find those angles, measure, and teach? Thanks, Callie. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Michelle, what's your favorite color? Blue, you got it. Michelle, will you please show me one of the angles that you figured out? So what was the first angle that you put down after you knew that the measuring angle SOW was 151? Perfect, please do. Yeah. Perfect. So she knew that vertical angle was... Awesome. How many of us got that? That's okay. That's okay. It takes practice to draw on this thing. How many of us got that the measure that this bottom angle here was 151 degrees? How many of us were able to get that? Good. Excellent. So we know the measure of angle ROD is 151 degrees. Very good. Let's see here. That's going to be, how about, let's see, that's going to be Jackson. What's your favorite color? Red, you got it. All right. Will you please write down what you think the other two angles would be? You're not sure? That's okay. So check it out, Jackson. What do we know about this 151 and that mystery angle? What do we know that they do? Oh, not 90. That's okay. They have to add up to 180. So grab your calculator and do something with 151 and 180, and then tell me what those measurements should be. Awesome. And then what would the other one be? Excellent. How many of us were able to get that those two angles were 29 degrees? How many of you were able to get that? Beautiful. Excellent. Thank you, Jackson. Very good. So once we know all that, we can tell what all those angles are. That's the whole point of doing the angle work last year, was I would give you one angle here, and then you would be able to tell me the rest. Here's how we're going to turn that into an 8th grade thing. Got a pencil? Oh, you can do better than that. Got a pencil? I want you to draw a line that is parallel, and this is really important, that is parallel to RW, right? To RW. Just try to make it go the same direction is what I'm saying. Then we need 3 more letters. I don't know, what are 3 letters that we didn't have here that spell something fun? Red, I've already got a D and an R. Cab? Cab works. Cab works totally. So here's the thing. In order for what we're about to do to work, these 2 lines have to be parallel. So we're going to write that 3 different ways. Parallel, saying that 2 things are parallel is so important that we actually have a bunch of different ways to say it. The first is the most annoying. You just write it out, where you could say, and I do want you to write this down, RW, the line RW is parallel to the line CB. Those 2 lines are parallel. Another way you could write that is you could just say that RW and then the special symbol for parallel are 2 little ticks. Looks like an 11. CB. That's another way you can say that they're parallel. You can say RW is parallel to CB. Right there. It's just fancy ways to say it. This is not something that you should be like, oh, how did he get that? Like, this is all stuff that I'm just telling you it's how we say that they're parallel, that they go the same direction. The last way, guys, is if you draw a little arrow on this line and you draw a little arrow on this line, see how they both have the same number of arrows? That means that they're parallel. So since this has one little arrow and that has one little arrow, that's another way I can tell you that they're parallel. You guys ever have this happen in a math class where, like, you're watching the teacher do something and you're nodding and you're like, this makes a lot of sense. I think I know what's happening here. And you ask your teachers, like, wait a minute, does that mean this? And your teacher looks at it and says, you know what? That would make a lot of sense. But no, that's not going to happen. How many of us have had that happen in a math class before? We were like, oh, great. But I'm here to tell you guys, is there something that you really hope is true about these angles down here with the pink line? How many of us that there's something in our head that we really hope is true about those angles? Well, guess what? As long as these lines are parallel, that is true. So when I say teach, I want you to say, okay, what do you think is true about the 4 angles that we made down here with cab? What do you think is true about these 4 angles? That thing that you hope is true is actually true as long as these lines are parallel. What do you think that is? Teach! Yeah. Well, tell me about what do you mean? So, like SOW is 151. That's okay. That's okay. No worries. You're good. Squeeze by. Hello, Kennedy. Uh huh. Let's talk about it. What you got? Yeah. Yeah, totally works. Yeah, because what you're doing is that you're saying that you know that there's a 360 degrees in a circle, and if you take those away, then what's left is both of these, and since they have to be the same, you can divide it by 2 and you're in business. Absolutely, Kennedy. That will work every time. Okay, can I get you guys back up here in 5, 4, 3, 2, 1? Izzy, what's your favorite color? Green. Okay. I want you to mark down in green something that you really, really hope is true. Mark down something in green that you really hope is true. Izzy really hopes that that's 151 degrees because if it was, this lower part would be a perfect copy of the upper part. And guess what? It is. It is. So what else has to be true, Izzy? I saw that on Izzy's paper, so she can go ahead and just do the whole thing. Yeah, that's going to be 29. That's going to be 151. That's going to be 29. Awesome. How many of us were hoping this was true and are super jazzed that that's true? Yeah, I know. Doesn't that make our lives easier? Thanks so much, Izzy. Good job. Yeah, so that's perfect. Let's see here. And it's so powerful. We can do all kinds of cool stuff with this. Like this. Got a pencil? Oh, boo. Guys, that was not the best absolute. There was like a sad muttering. That didn't really work out for me, guys. But I will say I definitely heard Michelle say absolutely. But I know I heard some others, but here's what I heard. I heard Michelle go, absolutely, and then I heard like, which is not the worst, but we could definitely do better. Got a pencil? Absolutely. There we go. Let's write this down, guys. Draw a pair of parallel lines like this. And we're going to label these a little bit differently. I'm going to call this line L and line M. You can use cursive letters to label your lines, line L and line M. And then I'm going to tell you that L is parallel to M. They are parallel lines. Now we're going to cross those two lines. We're going to cross those two lines with a line that I'm going to call T. That's the transversal. We cross them with transversal. And I'm going to tell you that the measure of this angle is 78.6 degrees. And you know what? You guys can tell me the measure of literally every other angle you see. Since I know that L is parallel to M, you can tell me the measure of literally every other angle you see. Why don't you guys go ahead and do that? Give it a try and teach! You guys feeling good on this table A? Okay. Table B, you guys are feeling good? Awesome. Love to see it. Yeah, helping each other out. I love it. Beautiful. I love that you went straight for that one. That's really smart, Penny, because the whole the formal way of talking about this is that we say that corresponding angles are congruent. So we know those two have to be the same. That's cool that you went straight for that. I actually really like that. I don't know that anybody else did. Let me see. You guys feeling good over here at table C? Okay. How about you guys over here at table D? You guys have got any questions? You feeling good? Can you go ahead and draw it? I can't help if I don't see anything. Beautiful. That looks lovely. Lovely, lovely. Lovely. How are you guys doing over here at table E? Is making sense okay? Beautiful. You'll love to see it. Table H is making sense to you guys?
Yeah.
Very good, very good. Love that. Ooh, look at that, Jace. Jace went straight for the alternate exterior angles. Oh, so did Yvonne. I love that. That's cool. That's really cool. Some people are doing this a little bit differently. I love it. Beautiful. Now, what about the other ones? What about the other ones? Beautiful. Very good. Look at that. Going straight for the corresponding angles.
Do I have to, because it's the same angle in here, do I have to write it twice? Or just...
I would put it in there. I would put it in there. Mm-hmm.
The other ones are 101 through 4.
Yes, Henry. Oh, perfect. Sorry, I was getting lost over here. No, that's great. That's great. That's all. That's what we need. That's part of your level 2 stuff. That's part of your level 2 stuff. If you can do that, you can get the level 2 questions. Hey, Jackson. It is. 100%. 100%. So let's see. It was. I saw Penny doing it, and Yvonne, and Kyson. I swear I saw one other person. Oh, Jace. Yeah. Jace, Kyson, and Penny. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Let's see here, guys. Let's see. I'm going to use some colors here to help us do this. Let's see. We'll go red, orange. That's not really that green. Green, gray, black, brown, and what am I missing? Purple. There you go. Perfect. Okay. So, looking at these angles, guys, which one was the first one that you filled in other than 78.6? Sammy, other than 78.6, which one did you fill in first? The red, orange, green, gray, black, brown, or purple? You filled in the red one. And how did you get the red one? Beautiful. Since those have to add up to 180, 180 minus 78.6 is 101.4 degrees. So that had to be 101.4 degrees. Awesome. Is that the first one that you did, Kenny? Is that the first one that you did? It was? Okay. Did someone do a different one first? Did someone do a different one first? What was your first one, Beckham? Orange. I think a lot of people did the orange one first. How many of us did the orange one first based on the blue one that I have up there? Yeah. And what does that one have to be there, Beckham? Perfect. And by the way, since that's 101.4, this green one's also got to be 101.4 degrees. Very good. Now, guys, you'll notice that I put Yvonne, Chase, Kyson, and Penny on the star team because they actually did something a little bit differently. They actually started, and you know what? We're going to bring these back in just a minute. So, is there a way for me to do this? This is going to get weird. Okay, hang on. Are you guys ready for some spiffy lassoing? Yeah, I'll bring those back in a little bit. I'm going to bring those back in a little bit. So I want to point out, Penny, what was the first one that you did? Was it red, orange, green, gray, black, brown, or purple? It was the black one. She went straight for the black one. And what was the measure of the black one? 78.6 degrees. She instantly recognized that those have to be the same, which is really cool because I totally get why most of us did all the 7th grade angles first and then moved down here. But I think it's really cool that we've got some people who are already recognizing that there are things that are congruent other than just take this and then glue it down here. Jace, what was the first one you did? It's the brown one, yeah. Jace actually did the brown one first. What was that one? Yeah. So Penny realized, even if she didn't think these words in her head, Penny realized that corresponding angles are congruent. Even if Jace didn't think these words in his head, Jace recognized that alternate exterior angles are congruent. And then I can just yoink these guys back. Whoop. And I can fill this in the rest of the way. Let's see, I've got a gray and a purple. What's the measure of that gray angle? Let's see, Bethany, what's the measure of that gray angle? 101.4 degrees. And then what's the measure of the purple angle, Adele? 101.4 degrees. Awesome. I really appreciate the attention you guys are giving. I think you guys do deserve a point for that. Thank you so much, everybody. I want to point out something really cool that Reese did with this as well. So when I don't know, I never saw Reese's paper, but it sounded like maybe she did this. Hang on, let's get some fancy lasso work. Whoop. So, Reese, did your paper ever look like this for a second? Yeah, so Reese filled in all of the 78.6s first. And then I heard her say, what? Do you remember what you said? Mm-hmm. Yeah, and then Reese just said, and the rest are 101.4. And that's absolutely true. Once you know all those, then you know that the rest have to be the same. The nice thing about this, guys, is there's only two values that we have. We've got the original and then 180 minus the original. How many people here feel like this is making some sense to them? You guys doing okay out there? That's excellent. I love to see it. Maybe we should dial it in. Big thumbs up. This is easy peasy lemon squeezy. This is a level 2. I'm going to get all those right. Big thumbs down. I don't understand a single thing that just happened here at all. And then dial it somewhere in between. Where is everybody? Where is everybody? Let's see everybody's thumb somewhere. Okay. I don't know what that was. All right. So let's do it, guys. At your tables, I want the person who has, how about I want the person at your table who has the fewest letters in their first name to come and bring me my rulers, check to make sure they're okay, then head back to your assigned seat. We'll continue our discussion about these tomorrow. Those of you at home, we will see